Hello and welcome to section 4.2. Here are the first three questions from last night's assignment, and you're probably not going to like these because they involve a lot of work. You're identifying what type of triangles they are based off their sides and their shapes, or their sides and their angles, and so you have to see if there's a right angle or not to determine if any of those are, if they're right triangles. You have to check their slopes. You have to do a lot of distance formula to do some measurement. So they're timely but important questions. So if you have questions on those, please see me. And a lot of the other stuff was a lot more straightforward, just triangle sum and the exterior angles theorem. You may have done these problems a little bit differently. If you did, that's okay. They're pretty straightforward. It's just a bunch of algebra. And then speaking of the triangle sum theorem, or sorry, the exterior angles theorem, this is your proof. I was very skimpy with it. For example, I didn't put the measure of angle 1, etc. This is just basically an outline of what the proof should look like. So if you have questions on that proof, please let me know. All right, we're going to be working with congruents and triangles today. In geometry, two figures are congruent if they have exactly the same size and shape. So imagine if you cut one of them out, you could place it directly on top of the other. It's going to fit perfectly. You may have heard the word similar, and that's the same shape but different sizes. We're working with congruency today. So in general, we're going to start off with all types of polygons, and then we're going to focus more in the rest of the chapter with triangles. So if two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure, meaning angle B and angle E are going to be equal. Angle A and F are going to be equal. C and D are equal, and then their side lengths as well. So all their corresponding sides and their corresponding angles are going to be congruent. So that's what we got going on here. It looks like a lot, but it's actually a pretty straightforward concept. And then here is this is called the congruent statement. If they ask you to write a congruent statement for the triangles, you're saying triangle ABC is congruent to triangle FED. You can use any order. So if this is another example. Just make sure that you're consistent. So the B matches up with the E, the C and the D, the A and the F. So write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So sometimes you're going to have to rotate the figures to make them match up. So like, for example, the K and the S match up, and the L and the R match up, and the J and the T match up. So I could go triangle KLJ is congruent to triangle S, and then now L matches up with R, S, R, T. The order matters. And to show that here, like I said, if you rotate this guy here like that, then now you can see that they match up nicely. And sometimes you'll have to rotate it, sometimes you'll have to flip it or reflect it. And then the corresponding parts, we have J and T. And I'm not going to write all these out. Angle J is congruent to angle T. And then you do all the other angles. And then you can do side lengths J and K and S and T. And then, again, there's three angles and three sides. So here they tell us that the two quadrilaterals are congruent. Find the values of x, find the value of y. So we can just look, and now, so Q, without trying to figure out what angle Q matches up with, just look at your congruency statement. So Q matches up with F, so I'm going to find F. There's F right there. So Q and F I know are equal. So you don't even have to try to guess which one goes with which one. 6y plus x equals 68. I can't solve that because I don't have x yet, so I'm going to figure out what x is. So let's find an equation with x. QR is right here, so there's an x right there. So QR matches up with FG. So QR matches up with FG. So I'm going to find FG. FG is right there, so that's 12. So my other equation is 2x plus 4 equals 12. So you're going to use the congruent statement to write your equal parts. So x equals 4. So I'll go over here now and then plug in 4 and then solve for y. Did I do something wrong? Oh, that's a -4. Shoot. Change that. Well, this turned into a disaster of a problem. Okay, so y equals 10. One little mistake and the whole thing looks like garbage. All right, but there you go. If you divide the wall into orange and blue sections along JK, will the sections of the wall be the same size and shape? So basically they're asking, are the two quadrilaterals congruent? That's what they're asking. So what I notice here with these lines right here is that since these are right angles, these lines are parallel. Now this would be a nice transversal there. So 3 and 2 are alternate interior angles. And 1 and 4 are alternate interior angles. And this side is reflexive. JK is congruent to KJ. So, yes, we can say that because all parts are congruent. All the angles are congruent, all the side lengths are congruent, therefore the two quadrilaterals are congruent. All right, the third angle theorem. This is really, really, really important. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. We're going to be proving this in exercise 28. It's a great proof. With that information, find the measure of BDC. This is the first of many times that you will separate triangles this year. Okay, and what I mean by that is you're going to take this triangle, and you're going to take this triangle, and you're going to separate them. It's going to allow you to figure out different parts of the triangles. Okay, and then, so I have some congruent angles here. So let's see, 45, that one's 45, and this one's 45, and this one's 30, and this one's 30. And they're looking for BDC. So BDC is this one right here. So that one would be right there. That's what we're looking for. So I have 30 and 45. That's 75. And they have to add up to 180 using the triangle sum theorem. So 105 is my answer. All right, and then write a proof. These proofs here in this section are basically show the angles are the same and show the side lengths are the same, and they give you most of the information. You just have to fill in a few parts. And so they're going to give you a lot. So they've marked all this. I'm just going to place that right here in the first line instead of write all that out and make a mess. So we have to show all three sides are congruent, all three angles are congruent. Two of the sides are already congruent. And so the third side, this is where the reflexive property is going to come into play. AC and CA are congruent. And the reason why I write it AC and CA versus AC and AC is because I'm trying to show ACD is congruent to CAB, and that is the proper order. So that is reflexive. All right, now I got to show the other angles are the same. Well, I have two angles congruent to two other angles. So that means angle D is congruent to angle B. And that is our third angles theorem. Please note there is no third lines theorem. That does not exist. So maybe you want to put that in your notes. All right, I just showed that all three angles are congruent and all three sides are congruent. So the two triangles are congruent. So now what I do is I say triangle ACD is congruent to triangle CAB, and then we say definition of congruent triangles or congruent polygons. Either or is fine for me. And then this same thing we've talked about reflexive, symmetric, transitive a lot this year. Same thing holds for congruent triangles. And there you go. Please let me know if you guys have any questions on this section. I'll see you guys in class. Also, I just added number 32. This is a great, as a challenge question. It's a great proof practice problem. So give that one a try if you want a little bit of a challenge.